Hello and welcome to today's lesson on calculating a z-value and using the z-value to find probabilities for being in specific intervals. Now, if you remember from yesterday's lesson or the last lesson on the normal distribution and what we call the empirical rule, we know that with a normal distribution, we consider it to be centered at 0, and then we use our standard deviation 1 of a counting tool. So we have 1 unit below average, 2 standard deviations below average, 3 standard deviations below average, and we have that tool and we use our empirical rule. 68% is plus or minus 1. Okay, so the majority of individuals are between 1 standard deviation below average and 1 standard deviation above average. And then we can spread out to our 2 standard deviations in either direction. And then we know that we've covered 95% of the population in that interval. And then if we want to spread out even further and we go plus or minus 3 standard deviations, okay, that covers 99.7% of the population. Okay, and we can use this to solve a lot of problems as long as the values fit perfectly on our 1, 2, or 3 standard deviation values. As soon as a value falls in between standard deviations, we can't use all these little chunks that we have and build together to find a probability. So now, when a value doesn't fall perfectly on a standard deviation line, we have to do a little bit more work. And what we have to do is find something that is called the z-score, or the z-value. Now, to find z, and z is the number of standard deviations above or below average, just like the distribution we saw, we take our number minus the average or the mean, okay, it can be called either. We divide by the standard deviation, and what that does is that normalizes the distribution. It picks up the entire distribution and sets it down at a center of 0, and by dividing by whatever the standard deviation was, it now makes the standard deviation a value of 1. Okay, so this is a normalizing process to make anything fit a given distribution. Okay, so now how do we describe and talk about these terms? If we say z is 1.75, okay, that means that whatever the value was that we started with is now 1.75 standard deviations above average, above the mean. Okay, so we know that that's an above average value. If we have a negative z-score, a negative z-score tells us that this value is 0.93 standard deviations below average. Okay, so using 0 as the center of the normal distribution, our z-values can be above or below, and now we can make comparisons and find probabilities. So now, if we want to find these values, we're going to use technology. The technology is going to help us find that value. And to be between these two numbers, we always just want to draw a quick picture. The picture is going to help us solve this. Understand that we've got our 1, 2, 3 standard deviation marks in either direction. Okay, I've got a negative 0.3, so I'm just below average there. And now I'm stretching up to 2.49, okay, and I want to find the probability of being in this range. Okay, now the important part is the piece that we're going to use for technology needs a lower boundary and an upper boundary. So when we go to the graphing calculator, we're going to go second vars, okay, that gets us into our distribution mode. And we're just going to pick this second one. Okay, it has to be a cumulative or a CDF situation because we're adding up probabilities for a range. Now, if you notice what it asks for a lower or left boundary. That is our negative zero point 0.3, and then we need an upper or a right boundary of 2.49. Once we have the two boundaries, notice we're not going to change these next two numbers. Centered at 0 with a standard deviation of 1, okay, and then we just paste that in, and the calculator finds the probability of being in that range for us. Okay, so we've got a probability of being between these two, okay, and we can write it mathematically, the probability of z being between negative zero point 0.3 and 2.49 equals 0.612. Excuse me. If we look at this next situation, find the percentage that is less than negative 1.87. Okay, so we have our distribution centered at 0. We're dealing with negative values here. Okay, so what we want to do is put in the given value that we have, negative 1.87. We want to be less than that value. Okay, so now I look at this shaded region. This shaded region has an upper boundary, but it doesn't have a lower boundary. Okay, what we have to do for our lower boundary is our lower boundary technically is negative infinity. Okay, the calculator doesn't have a negative infinity button. Okay, so we have two options for negative infinity as a lower boundary. We can do negative 10 to the power of 10, or we can go negative 99999 and just put in a bunch of 9s. Okay, the numbers are very different, but it does the same thing for us overall. Okay, so now the important part, like I said, is seeing the picture, being able to build through and find your lower boundary. Okay, I'm going to use the negative 10 to the 10 in this case. And then we need our upper boundary, the right boundary of this interval, negative 1.87. Make sure you get your decimal place in the right spot. And then we just enter through, and we're able to get our probability for that value. Okay, negative 0.307. Okay, so we found our probability for that one, the way that we would write this. Okay, the probability that z, our standard value, is less than 1.87 equals 0.031 to 3 decimal places. Always be careful of the rounding and how you're asked to round in your individual homework. Okay, now, last one that we have is a greater than situation. Okay, so we once again in a greater than situation, centered at a value of 0. Okay, we want to draw our values working up. Hello? We've got our value of 0.61. Okay, so we're not a full standard deviation above overall. Okay, so we've got our positive 0.61, and we want to be greater than that. Okay, so we're shading our graph. And now we notice we've got a lower boundary, but we don't have an upper boundary. Okay, this upper boundary is positive infinity. And like we know from before, the calculator doesn't have a positive infinity button for us. So we're either going to use 10 to the 10 or a whole bunch of 9s. We just need a large value to make sure that we've accounted that we've gone far enough out in this interval to take care of it. Okay, so now we go to our calculator. The steps are the same. Normal CDF. Once we have that, our lower boundary of 0.61, our upper boundary of positive infinity. This case, I'm going to drop in a bunch of 9s. Okay, it doesn't matter. Just put in a long string. And then we enter, enter, enter. and then it finds the probability of being in that range. Okay, and you want to make sure that your answer makes sense based on what you see in your graph. Does it make sense that that green shaded region, the probability of z being greater than 0.61 equals 0.271 or 27.09% of your graph? Okay, you want to make sure that these make sense overall. Okay, so that is how we can use z-values and boundaries to find the probability of being in a region. Okay, now the other advantage of a z-score is to be able to compare values that are not on the same scale. Okay, so if we look at Julia's scores here in her different classes, okay, if we're just looking at raw numbers, we know that geography and Spanish are the classes that Julia did best in. Okay, but now that's based on a raw score. What we want to do is we want to find out what's her distance from the average based on a standard deviation. Okay, so we want to turn these scores into z-values. So for math, her z-value is her score of 48 minus 40 divided by 4.4. English, her z-score, 81 minus 60 divided by 9. Okay, you can see these spread distances, the standard deviation distance, is different for each of these cases. In geography, her z-score, 84 minus 55 divided by 18. Okay, so we're going to use the calculator to find these values. 48 minus 40. Be careful when you enter this one. I always hit enter here first before I divide to make sure that I don't make a mathematical mistake. So Julia's z-score in math is 1.82. She is 1.82 standard deviations above average in math, even though her score was only a 48. Okay, and then we've got 81 minus 60. Enter. Divided by standard deviation of 9. Okay, in her next class, okay, English. Okay, she's performing 2.33 standard deviations above average. Okay, that's got to be one of her best classes. We'll see how the rest of these play out. 84 minus 55. Enter. Okay, now that's a big spread, but notice that we're dividing by 18, which really shrinks down that value. It was her largest raw score, but it's not her largest z-score overall. Okay, and then we finish up 68 minus 50. Enter. Divided by 20. Okay, 0.9, less than a standard deviation above average. And then we finish up with 84 minus 50. Enter. Divided by 15. Okay, now we've converted all of her grades to z-scores. So now if we want to rank how Julia did, her best class right now is English. She's performing 2.33 standard deviations above the average student. Then Spanish is next, followed by math, then geography, and then we wrap up with biology in order from best to worst. Okay, so that's our lesson for today. Finding the z-score for individual values and using the z-score and our normal CDF function to find the probability of being in specific ranges. Thank you and have a good day.